The University of Technologie of Compiegne, so as it is said in the title, it's in Compiegne at the north of Paris. It's one of the three University of Technology. It's the best from the three, and it has about 5,000 students, and we work in the field of mechanical engineering, but also biotechnologies, processing technology, and all the main scientific fields. I think nowadays the physics fundamentals are about to be forgotten, in fact, by engineers, students. So it's really important to talk about electricity, basics of electricity, basics of mechanics, basics of electromagnetics. I want to know how many watt or kilowatt go in the structures and where they go out. And ANSYS is able to decompose, to compute the full balance on each boundaries of the structures. And last thing I teach with ANSYS is thermoelectricity. So the basic of electricity is the Joule effect. The Joule effect. So this is a coupled problem. You have two physics. It's quite easy to understand that the more electricity you put, the more heat will be dissipated by the Joule effects. And we may quantify all this heat flux in order to make the balance, to understand where the heat birth and where the heat goes out in the problem. So very, very simple problem on which you may have talks not for days, not for hours, but maybe for 1 hour. And you illustrate it with great peaks and very easily with the APDL script, because you can use parameters to change the structure dimension, to change, for instance, the heat transfer coefficients for convection around a beam, things like that. We use ANSYS as a virtual laboratory in order to test our ideas, in order to test our models just by the means of our mind. And it's very interesting for us, because ANSYS is a code that is really close to the physics. ANSYS is the best because it's easy to script in ANSYS. It's easy even to batch some post-processing. Every finite element engineer knows that the most difficult part is not building the model, it's not solving the model, it's post-processing the model. And about post-processing, ANSYS, it's very great. You have several modes. You can batch with APDL, the post-processing. For instance, I may generate about 10,000 peaks with ANSYS automatically, zip them in an archive that I download back, and then unzip. I do not know other codes that are able to do that, for instance. ANSYS also is the best at the way it manages the computing resources. Like CPU, ANSYS will use the less memory it can, and the less memory compared to the other codes. So it's very, very good to us, because it means we do not have to have big computers to solve standard models. It has built in all the multiphysics we need. I may do thermomechanical analysis, electrical analysis, thermoelectrical analysis. I may couple magnetic fields, electric fields, mechanical fields, and also with the fluid, but with Fortran, and not the last thread, because all is built in ANSYS Classic. And even if I want to be much more modern, like the PhD students that I have, they use Workbench, then couple fluent with ANSYS mechanical PDL, or they may choose CFX, for instance. They even have the choice about the fluid solver. So it's very wide solution, all built in one product, very convenient for us. Very convenient. I've chosen to go to ANSYS because to me, simply, it's the best code when you compare on all the features to the other ones. It's obviously the best.